Morning, guys. We'll wait for a couple of minutes and then we will start. Okay, let's start. So yesterday I was trying to explain you the resource allocation and resource valuation problem. I was trying to give you an example of that you have this window glass company and I'm trying to buy it. Now let me try to put it in other words so that to make the example more clearer. Suppose you own this company and you have resources in different plants, okay? And resources, at least for this problem, we are explaining in terms of total hours. Okay, so you have this 4, 12, and 18 hours of resources in each of the plants. Now you decided, how do I allocate these resources to maximize my profit? Is this clear? So first, you allocated these resources such that you can produce maximum of X1 and X2 to maximize your profit. What you did, you attached a cost to each of the resources. Like if I use 1 hour of my resource in plant 1, it will cost me Y1 rupees. Or if I use 1 hour of resource in plant 2, it will cost me Y2 rupees. Now you want to do a resource valuation. You want to value how much your resource is worth, so that if someone tries to buy your company, what should be the minimum price of each resource you are willing to sell. Now, does it make sense? Yes, no, no idea. कुछ तो बोलो. सो रहे हो सब? Come on, wake up. If you do not say anything, I would expect that understand that you have understood, and I will proceed with the further syllabus. So just if it is not still clear, discuss with me. Do not worry what other people will think about your question. Anyway, whatever you decide, it's becoming clear. So you try to evaluate do the evaluation of your resource. You also hear these terms like his valuation is this much crore or that much crore. So what we are trying to do, we are trying to value our resources, but this is a kind of a cost for me because 1 hour if my machine runs, it is a cost to me. So I decided, okay, whatever number of total number of resources I have into the unit cost I will multiply and add it up and see what is the minimum it is coming. Second, suppose if I use 1 unit of resource in plant 1 and 3 units of resource in plant 1, corresponding money that I'm spending is 1 into y1 and 3 into y3. It should be at least greater than equal to the profit I am making. If it is not, if it is less than equal to profit I am making, then it means that I'm not really using my resources right. So if someone comes to buy my resources, I need to ensure that whatever price I sell it to them, it should be greater than the profit I am making from product 1 and product 2. That's why 1 into 3x1 is greater than equal to 3 and 2 into 2y2 into 2y2 or y3 should be greater than equal to 5. At least the profit which I am making, if see, if I'm already making enough profit, I will not sell my resources. But if someone comes and tells me, okay, I will give you at least what you are making or more than that, then only I will be willing to sell my resources to that company or that person. Does that make sense?
Yes, sir.
Yes, sir.
So this brings us to this is the idea behind it. This brings us to what is we call primal dual relationship. So just a second. Primal dual relationship. So that is from economics and understanding. I explain it to you. Now, just a second. Sorry, guys. So every yes.
Sir, here, for plant one, we have 4 hours of like resource, and Y1 is the number of hours we are buying from like the company, right?
Y1 is the price.
Okay, Y1 is the price.
Y1 is the price. Hours are 4 hours. So for each 1 hour, how much price I'm willing to, if I'm a bigger company, how much price, not I should say willing to, I would say I should make an offer to buy hours from in your company and how much I should pay you so that you are happily ready to give me those resources or the hours. Does that make sense?
Yes, sir.
Okay, so primal dual relationship, when we come to primal dual relationship, it is every LP has another LP. Every LP, let me call it primal for timing. I will explain what is primal. has another LP. So the original problem is called primal, and corresponding dual is called dual actually. So if you look it from the representation structure, it is primal problem we generally represent as maximize G equals to Cx such that Ax is less than equal to B, x greater than equal to 0. If I'm converting or making its dual, it is minimize W equals to YB, YA is greater than equal to C, and Y is greater than equal to 0. Let's see if that is the case we have done or not in the just example of window glass. So this is my primal problem and this is my dual problem. See, in fact, it is difficult to see. I will write it again. Maximize G equals to 3x1 plus 5x2. x1 is less than equal to 4, 2x2 is less than equal to 12, 3x1 plus 2x2 is less than equal to 18, x1, x2 greater than equal to 0. Minimize W equals to 4y1 plus 12y2 plus 18y3, 1 plus 3, y1 plus 3y3 is greater than equal to 3, 2y2 plus 2y3 is greater than equal to 5. So it's there y1, y2, y3 greater than equal to 0. See if it is matches the the matrix representation I have shown you above or not. Oh God. It matches.
Yes, sir.
So more precisely, we can write C as 3, 5, A as 1, 0, 0, 2, 3, 2, and B as 4, 12, and 18. In this case, my C actually is 4, 12, and 18. A is 103, 022, and B is 3 and 5. So C with B replaced here. A, now look at B. The reason I have put B because it is a transpose. Okay. Now Y is in the front and A matrix, which is the transpose, is in here. And B matrix now becomes C, again it's transpose. So this is how we can write dual of a primal problem. Now suppose if I say, when we look at a problem, can we say it is a primal or dual? Suppose I have given you this problem. Is it a primal problem or dual problem? Since I'm saying this is the primal problem, find the dual problem. But if some formulation is given to you, can you say it is a primal problem or dual problem? Are you understanding my question?
No, sir. I think we can find the which is one is primal or dual.
Actually, if I give you a formulation, suppose मैंने तुमको दिया maximize G equals to 3x1 plus 5x2, x1 is less than equal to 4, 2x2 is less than equal to 12, 3x1 plus 2x2 is less than equal to 18, x1, x2. We call it a primal problem, right? But suppose I gave someone this problem. For him, this will be a primal problem, saying that the whatever formulation I have initially is my primal problem. So can we say dual of dual is? Dual of dual is?
Prime.
Primal. So dual of dual is primal. So the person who has got this as a original problem, for him, this is the dual problem. The person who has got this as original problem, this is the dual problem. Interestingly, when you are solving primal simplex, okay, now going forward, I am calling simplex as primal simplex. Reason being, at the end of this topic, we will discuss dual simplex also. And dual simplex makes life much easier. No need for big M, no need for two-phase. Just negative RHS, anything is fine. So, at any iteration, when you are solving your object, any problem, x1, x2, xn are the original variable and these are the slack variable. Okay, here is the RHS. Iteration 0, sorry, iteration any, basic variable g, 1, equation 0. The values which you get here. Okay. Interestingly, the values you get here below the slack variables are actually value of your dual variables. Not yn plus n, but yn. So suppose you are solving a simplex and when you look at primal problem, we are solving a primal problem. Actually, at the same time, you are also solving another LP, which is the dual of this primal problem. And this is your value of dual variables. But when I say dual variable, until you reach the final iteration, until you reach the final iteration, the values you get for your y1, y2 and so on will be infeasible. So when you are solving primal simplex on RHS, you are getting the value of primal feasible solution, but the dual feasibility will not be there. At the final iteration, you will get Cx equals to Yb and the values y1, y2, y3, whatever dual you are getting, that will be a feasible solution. So at any iteration, what you will see, at any iteration, primal solution, which is on the RHS, is feasible. You make sure that your RHS is always greater than or equal to 0 when you are trying to solve. At any iteration, dual solution coefficient of slack in zeroth equation, which is y's, are infeasible. At the final iteration, what you will see, x is feasible, y is feasible. I will also give an algorithm for this one, and Cx equals to Yb. So whatever value you get for your, like suppose 36 you have got for this problem, same 36 you will get for the dual solution as well. Does this make sense?
Yes, sir.
Yes. So now small economic interpretation of duality, and then I will come back to the simplex table again. Economic interpretation of duality. It's a very important concept. So when I write W equals to Y1 B1 plus Y2 B2 and so on, YM BM. Okay. Each of these terms Y1 B1 actually can be understood as the current contribution to profit having BI resources or BI units, let me say BI units of resources, because our resources kind of resources changes all the time. BI units of resources I made available to primal problem. Just read this statement. As I said that G star will be equals to W star.
Sir, what is G star here?
What is G star? Tell me. What is
The
G?
value of G at
It is the optimal value, right? The maximum value you will get for the problem. Cx star equals to yb star. Now, does it make sense?
Yes, sir.
जो तुम्हारा फाइनल आइटरेशन में जो x स्टार और सॉरी y स्टार नॉट y स्टार b स्टार whatever final iteration optimal solution you will get, you will plug in into your objective function. So for primal it is cx and for dual it is yb, right?
Yes, sir.
So for this problem, which we already know, for window glass, it will come 36 and 36. Now what I'm saying that each of these terms Y1, B1 is the current contribution to profit having BI units of resources. So if this is the price associated with it, I will also name it. It is a very important variable in the economics. It's called shadow price. If this is the price associated with it, this is the contribution they are making towards the profit. If I have B1 resources, suppose B1 equals to 4 into Y1 is the contribution towards the profit. If it is 3, then 3Y1 is the contribution towards the profit, because all of them will sum up and become equal to this only. Make sense? Is it making sense, guys?
Yes, sir.
Yes, sir.
Second point is the dual variable. So now going forward, we'll call yi as dual variable. Is interpreted as the contribution to profit per unit of resource I when the current set of, and this is where it becomes very, because of this line, it becomes very important for sensitivity analysis. When the current set of basic variable is used to obtain the primal solution. So think of it as, suppose you have purchased some machine, okay? Now you are running the machines hourly, that cost you something, and based on that you are producing some product and you are selling into market. Now you want to understand that machine which you have, purchased, how it is making contribution towards your profit, because products are being made on the machine only. So in this case, we are talking in terms of hours. So let's say plant 1 has 4 hours. So how 1 hour I use in plant 1 is contributing towards my profit? That's what we are trying to understand, which we say resource valuation problem. So this brings me to a very important terms in economics. It's called shadow price, which is nothing but your dual variable yi, which says the shadow price of resource I measures the marginal value of the resource. Just a second. Okay, resource I. Okay. Or in terms of our algebraic language, what we say, the rate at which G could be increased slightly. You cannot make a lot of bigger move because that may change your basic variables by increasing the amount of resource BI being made available. I will try to explain this with our window glass example. So suppose maximize G equals to 3x1 plus 5x2 and x1 is less than equal to 4, 2x2 is less than equal to 12 and 3x1 plus 2x2 is less than equal to 18, x1, x2 greater than equal to 0. This is what we found the optimal solution as x1 star 2 and x2 star equals to 6. Okay. Now, what shadow price is? So the dual variable associated with each constraint is y1, y2, and y3, and I will call them their shadow prices. Okay, so when you solve the simplex in the last table, in the final iteration, I'm only writing the zeroth equation, basic variables equation. You will get x1, x2, x3, x4, x5. So x1, x2 are original variable, x3, x4, x5 are your slack variables, and RHS was equals to 36. And I'm also writing the value which we got was x3, x2, and x1. 1, 2, 3, 2, 6, and 2. x1, x2 it was 0, x3 it was 0, x4 3 by 2, and x4 5 1. So as I said, this is the feasible value for, I'm talking about the last iteration. This is the feasible value for your excess. It always remains feasible on this side. And this value which you get at the final iteration, this is the only value which will be feasible for dual. Okay, before that iteration, whatever number you get here are not They are dual solution, but not dual feasible solution. The moment you achieve feasibility in here, you are actually at the optimality. I will show with a graph how it proceeds. Now 0, 3 by 2 and 1, what it means. So I just said these are the values 0, 3 by 2 and 1. If I increase this resource 4 to 5, do you think there will be any increase in the profit? If I increase this resource, first resource from 4 to 5?
Yes, sir.
If I increase 4 to 5, whether there will be an increase or not?
Yes, sir.
Yes, increase will be there.
अच्छा ठीक है, बताओ कैसे होगा? Just draw the curve and tell me. So right now your equations were like this. This was x1 equals to 4, this was x2 equals to 6, and this was your 3x1 plus 2x2, right? If I increase to x equals to 5, does my basic variables change? Are you guys getting my question? I increase this resource from RHS of first equation from 4 to 5. Whether it will affect my objective function or not.
No, sir.
It will not affect. And you know why? Because its shadow price is 0. But if you increase this from 12 to let's say 13. So right now I have x1 equals to 4. 3x1 plus 2x2 is like this. And from 12, I'm increasing it to 13. Whether my optimal solution changes or not.
Yes.
Okay.
Yes, sir. It will.
Do one thing, maximize, because unless you do it by yourself, you won't be able to understand. Solve this problem graphically and tell me the value of x1 and x2. x1 star and what is x1 star and what is x2 star. Give me these two values. And obviously, let me call it G dash, because find the value of G dash star. Give me these three values, then I will try to explain what shadow price means. You guys have already solved this problem. We just need to find x2 and x1 from here, the intersection of these 2 points.
That is 37 point.
X1 is how much?
X1 is a 5 by 3 and Y1 is
5 by 3.
Yes, sir.
And next to
13 by 2.
13 by 2.
What is G star?
37.5.
37.5. 37.5. So if I take delta G equals to G dash star minus G star, which we have got earlier, what is the increase? 1.5. 37.5 minus 36. Is this correct?
Yes, sir.
Yes.
What is the dual variable associated with it? What is the value?
1.5.
1.5. So if you make available 1 unit of resources, so the rate at which G could be increased by increasing the amount of resource BI being made available. So if I increase 1 unit of resource to delta G is nothing but Y2 into delta B2. Whatever increase you have done, but as I said slightly because it has a meaning. The meaning here is if this is my feasible region and these are my basic variables x1 and x2, if I increase or decrease too much like 10 or definitely we'll find this how much we can increase and decrease in sensitivity analysis. If I increase too much, the feasible region structure might change and this may not be or the basic variable set which is right now x1 x2 may change to x1 only and other are the slack variables. So we cannot increase drastically, but if slight increase, delta G is the marginal increase because of the dual variable. So is the funda of shadow price clear to some extent?
Yes, sir.
Now यहाँ पे एक और चीज देखने लायक है x1 less than equal to 4, 2x2 less than equal to 12 and 3x1 plus 2x2 less than equal to 18. At the optimal solution, I have 2,6. So 2 is less than equal to 4. 12 is, I'm plugging these values in this equation. 12 is equals to 12 and 18 is equals to 18. So these two constraints are active and they're fully satisfied, right? And this constraint has a slack x3 equals to 2. So whenever there is a slack, corresponding dual variable becomes 0. Whenever the slack is 0, dual variable becomes greater than 0. How much y3 was equals to 1. Did you hear my statement clearly?
No, sir.
Yes, sir.
Whenever there is a slack present in the at the final equation, then corresponding dual variable becomes 0. That means even if you increase it, there is already slack in that equation. This is not going to help you in increasing your profit. But if there are no slacks, that means slack equals to 0, you will have a positive shadow price. Positive shadow price means, more importantly, you can relate with active constraint. Shadow price for you to remember. I also write the dual variable is greater than 0. Inactive constraint or non-binding constraint, shadow price equals to 0. Good enough. So positive shadow price says it is a scarce resource. If you want to buy, so there is another way to look at it also. How much maximum, suppose you want to increase profit, what is the maximum amount of money you are going to spend to buy 1 unit of resource at plant 2? So my question right now is, if I tell you I can give you 1 more hour at a particular price, so think of it as I'm giving you a new app that can increase the number of hours from 12 to 13 in plant 2. What is the maximum price you are willing to pay for that? Are you getting my question? Guys, what
Sir,
is the
equals to the shadow price.
okay, Vishal? Anyone else? So if I want to increase 1 unit of resource in a plant to, if it is greater than 3/2, then I'm not making any increase in the profit. Does that make sense?
Yes, sir.
So the maximum price I'm willing to pay is 3/2. So although it is 1.5 rupees or whatever it is, but I will try to negotiate. So I know the number at which I need to negotiate. So that is the whole idea. When you are planning to sell your companies, you should know what is the price at which you have to negotiate. If you go below this, above this, you are losing. I mean, sorry, when I'm selling, I have to have a price greater than this. Then only I will be able to compensate for my profit. Now I'm giving you a list of how to convert a primal problem into dual problem, but please make sure this is in the standard form, the form which I'm giving. So primal is, if it is primal is max type, then only you can use dual to convert minimum. If your primal is minimum type, you have to use it, you have to look it from the right hand side. So corresponding table I will give, and this will help you in creating the dual of a primal problem. So primal problem, let me write the A, B, C, ith equation, ith constraint, sorry. Constraint, ith constraint, ith constraint. Okay. Xj variable, xj variable, xj variable. So in primal problem, A is a technology coefficient matrix. B is your RHS vector. C is your cost vector. If ith constant is an equal to type, ith constraint is an less than equal to type, ith constraint is an greater than equal to type, xj variable is unrestricted, xj variable is greater than equal to type, xj variable is less than equal to type. So how do we convert? If this is the cases, these are the cases, how do we convert its dual? So for dual, A matrix becomes transpose of A, B matrix becomes cost vector, C matrix becomes RHS vector. Okay. If primal problem is ith constraint is equals to, let me write this. If ith constraint is equal to, the dual variable is unrestricted. Yi is unrestricted. If ith constraint is less than equal to, the dual variable yi is greater than equal to type. If ith constraint is greater than equal to, the dual variable yi is less than equal to type. Now, if xj variable is unrestricted, the ith constraint, sorry, jth constraint will be equal to type. If xj variable is greater than equal to 0, the jth constraint would be greater than equal to type. And if the xj variable is less than equal to 0, the jth constraint will be less than equal to type. So this is a master table for you to remember how to convert. Okay, this is the master table for converting any primal problem into dual problem. We'll quickly use one example to explain this. So let's say my primal problem is given as maximize g equals to x1 plus 4x2 plus 3x3 such that 2x1 plus 3x2 minus 5x3 is less than equal to 2, 3x1 minus x2 plus 6x3 is greater than equal to 1, and minus x1 plus x2, not minus, I think it's just x1, x1 plus x2 plus x3 is equals to 4. Okay, and as far as variables are concerned, x1 is greater than equal to 0, x2 is less than equal to 0, and x3 is unrestricted. You need to convert it into its dual. So I will work with you. So this is the primal problem. We need to convert it into its dual. So let's start with the objective function. So this is maximization. It will become a minimization problem. We'll write W. Now, as far as C matrix is concerned for a dual problem, it becomes the RHS vector. So 2, 1, and 4. For your reference, you can always write the y1, y2, and y3. Always the number of variables equals to number of constraints. So minimize W, y1, y2, y3. So 2 into y1 plus y2 plus y3. Is this clear? Sorry, for y3. Is the objective function clear for dual? See, the RHS vector
Yes,
becomes the cost vector. Okay. Now let's write the constraint. Constraints are very interesting. Such that, so let's look at the, how do we write the constraint? So we have already seen that coefficient matrix becomes transpose of A. So we have to work like this. So 2 into y1 plus 3 into y2 plus 1 into y3. What I did? 2 into y1 plus 3 into y2 plus 1 into y3. Should be RHS becomes your the RHS vector becomes the cost vector, so it should be equals to 1 here. Now, can you tell me the sign of this equation? Greater than equal to, less than equal to, or equal to?
sir, greater than equal to.
Based on which criteria, where are you looking at the table to decide whether it will be greater than, less than?
Sir, ith constraint is less than, so
No, you are not looking at the right place. To decide the sign of the constraint, you need to look at the variable type, right? The constraints for the dual are decided based on what is the sign of your variables. And thus constraint on the primal side decide what would be the nature of dual variable. Is this clear? Is this clear, guys?
yes, sir. Yes,
So for this is the first constraint. So I need to look at the first variable, which is x1. X1 is greater than equal to 0. If xj is greater than equal to 0, corresponding constraint number will be greater than equal to that. Fair enough? Understood? Now, give me equation number 2 and 3. So tell me the second constraint.
So 3y1
3y1, 3y1
minus y2
minus 1y2
plus y3
plus 1y3.
is less than equals to 4.
So this less than equal to on what basis you have decided?
Sir, x2 is less than equals to 0.
Very good. Similarly, when x3 is unrestricted, you can say it is equal to. So the last constraint would be, actually it was minus 5y1 plus 6y2 plus y3 is equals to 3 because my last variable is unrestricted. So now you learn how to create a dual of a primal problem. Is that correct?
Yes, sir.
So you can use this table. I will come later. Let me explain all these things. How exactly this table has been derived, I will discuss with you later. So your class test 1 syllabus is until this point. So your class test 1 will be scheduled for the week of 21st of February. I will tell you the exact date, mostly on Friday. So your class test 1 will cover syllabus will cover all these whatever I have taught you from the start of this semester until this point. I will not be giving any homeworks on the these two parts. What I will give you, or should I give you a homework so at least you will practice? What do you think?
Sir, can you please upload some solved example on the whole mechanism we use in this work?
What do you mean by solved example?
So that, sir, if we are stuck at one place, so that we can refer from there.
You guys have the any one of the book Taha or Hiller and Lieberman and all?
Yes, sir.
So there are some examples. In fact, most of the examples I'm taking from there only to explain you. But what kind of solved examples you want?
So just like we have to first we have to make the LP for formation for the some problem, word problem, then to solve it, such kind of.
Okay, I will see, but I don't see that is pretty much equivalent to giving you a homework assignment, right?
Yes, sir.
Yeah. So anyway, I will see what can be done. For this part, maybe I will not give you any problem. I will give you some practice assignment, which you can practice before the exam so that you are ready for the part of the syllabus on which I have not given you any homework so far. Or maybe even if I give you a homework by today, you will have a good 10 days to work if I keep the date to 20th. Okay, let me see if I can give you a homework assignment and then I will upload the answer keys. So for you might have noticed that I have already uploaded solution for homework assignment number 1, right? So I have already uploaded